In this third section, we will look at soaps and detergent, softening hard water, purifying the water we drink, and treating wastewater. So first we're going to look at soaps and detergents. Soaps and detergents are used to take two substances that normally would be insoluble and allow them to attract each other. It acts as a go-between. So how does that work? A soap molecule will have one side that has induced dipole, so it's nonpolar, and one side that has ion dipole or dipole, so some sort of charged end to it. The charged end will be attracted to something else that is charged. For example, water is usually what we're attracting to. And then the nonpolar end will be attracted to your oil, your grease, whatever wouldn't normally mix with the water. And so the soap pulls the water on one end, it pulls the grease on the other, and they both wash down the sink. So this is what it can look like. Here is a soap molecule. You have an ionic portion on one end. Notice you've got an Na plus and an O minus there. And the other end has a bunch of carbons and hydrogens. They're not going to be polar. And so those nonpolar ends are going to surround Bob the dirt here. And then that charged sodium end is going to be called your water attracting, your hydrophilic end will be attracted to the water. The hydrophobic, this long chain of fat, called a fatty acid, on the right will be attracted to Bob the dirt, and the whole thing will wash with the water as it goes through. Soaps are usually made from animal fat and sodium hydroxide, and that gives them usually 3 fatty acid molecules to each charged head. Detergents are made from sulfate or sulfonate groups attached to one nonpolar tail, and they tend to be cheaper and more biodegradable than the ones made from animal fats. So usually now when you're doing your laundry or doing your dishes, you're using a detergent, strictly speaking, not really a soap, because the soaps are the ones we knew how to make from animal fat. Detergents we're able to make a little more specifically to clean a little better. Hard water can be a problem. A lot of your water contains calcium and magnesium, and those form compounds and collect in the sides of your pipes. Here's a picture of it here. It's really kind of gross. And those deposits form when the hot water combines with anions to form solid compounds. So if you've looked inside of a tea kettle, you'll see those solid compounds kind of coating the edge there. Sometimes in your bathtub, if you haven't cleaned it for a while, you can get some of the compounds coating your edge there. That's your hard water showing up. The inability of soaps to combine with the polar heads of these and not combine well with water often leads to a buildup of things like sodium carbonate. Or a buildup. And then the sodium carbonate comes and it attracts the calcium and the magnesium, breaks them down so that the soaps can do their job. So we'll use a water softening unit sometimes, and that does an ion exchange to take out your calcium and magnesium and replace them with sodium usually, which does combine with water really well and washes away. Or sometimes you'll do it on the other side of things where you have to scrape out your pipes. So it's better to have the water softening taking place, but keep in mind if you have the water softening, you're going to have sodium ions in your water there. The water that we drink needs to be potable. It needs to be safe. And there are a lot of places in the world where it's still not safe to drink, and you end up getting infections or poisoning or things like that from drinking. So there are steps for making water potable. The first is you've got to remove the dirt and pathogens that are in it. They mix it with slaked lime and aluminum sulfate, which causes the solids to gel, and then they filter that through sand and gravel, and the gel stays on top, and they're able to get those out that way. They can improve the odor and flavor by adding oxygen to the water, kind of bubbling oxygen through it or somehow spraying it through the air, That causes a lot of the unpleasant compounds that cause smells and tastes to be removed. And then to kill the remaining pathogens, they treat them with chlorine or ozone. It depends on where you are as to where they treat them. In the US, it's generally chlorine. A lot of the places in Canada will use ozone. About 300 people worldwide die each hour from diseases that they get from contaminated water. So although we have this wonderful system in the US, not everyone is so lucky. So to purify water, we can do what I just described, or they can do desalination of the ocean. But it tends to be expensive and difficult to do, and so it's not always the best thing because of how it's done. But if we need to do it, we can. This is what you can do. You can do reverse osmosis. So basically you have a membrane that only allows water through, and you take your seawater and you put high pressure on top of the seawater, and it will push the clean water through while leaving the salt behind. And then you clean that out, put in some more salt water, and just keep going like that, and you get pure water out. Normally, osmosis actually would make the water go the other way. It would go into the salt water. But because of the high pressure applied, it goes into the clean water. But that high pressure takes money to apply, and so it's cheaper to take wastewater from people and clean that than it is to take seawater and turn that into something that's potable. So how do you treat wastewater? Water that goes down the sink, shower, or toilet often ends up in a wastewater treatment plant. And it's got to be treated before it's released to a river, ideally, or to the ocean. And it also has to be treated if it's going to be turned into drinking water. So this is the way they do it. First, you screen out all the insolubles, toilet paper, grease, things people have put down the drain. And then you do primary treatment, which is where you put it in a basin, and the suspended solids are moved to the bottom as sludge, and the sludge is taken out and sent to the dumps, or it's burned. And then sometimes a second or third treatment is also done to decrease the chances the water is containing pathogens when it reaches a main water source. They clean it with chlorine gas, ozone, or ultraviolet light to kill the pathogens that are in it.